Okay, students, I will start the session. Good morning, one and all. Today's topic is piezoelectric transducer. Piezoelectric transducer means previously we have seen that piezoresistive effect. Piezoresistive effect means I am going to apply some pressure or force upon some material, and it is going to be converted into resistive type of resistive. It is going to give some resistance change in the resistance value like that. Here, same some pressure is going to be applied. It is going to be converted into electrical form. That electrical form maybe in terms of uh, voltage or current. I am going to acquire that is going to be measured by using some voltmeter or some ammeter like that. Okay. Here, piezoelectric transducer. It is a symmetrical crystalline material. Let me let me take this one. Okay. Asymmetrical crystalline materials such as quartz, Rochelle salt, and barium titanate produces an EMF. It is going to produce it is going to produce some EMF when they are placed under stress, and it is going to if those materials are applied some stress or pressure or some force, it is going to give some output voltage here. Internal variations in the material may takes place. For example, all the particles in the material, all the all the all the charge like that alignment. me- The initially the alignment of these charge carriers, due to that charge carriers, the alignment is like this. Assume that it has the alignment is like this. If I am applying some force or stress is applied, this alignment is going to be changed like this. It is going to be changed in some other directions. It is going to be changes. Some stress is applied like that. In the straight fashion, initially it is all the all the all the charge carriers are aligned like this. If I am applying some force or stress upon this material, this alignment may varies here. That due to that misalignment, I'm going to acquire some EMF in this material like that. Here, this property is used in piezoelectric transducers. I am applying the piezoelectric. I am going to use the piezoelectric materials like quartz, Rochelle salt, barium titanate, like that. Here, this property, these materials possess the piezoelectric properties. These materials possess piezoelectric properties, and those those materials I can use in the piezoelectric transducers. I am going to use those materials in piezoelectric transducers, where a crystal is placed between a solid base and the four summing member. And the four summing member, let it be, it is just like a spring. A four summing member is just like a spring, like this. It is going to be viewed like this. Upon this one, I am going to apply some force. You will see the diagram. An external applied force entering the transducer through its pressure port. It is going to be externally applied force is going to be entered via this pressure port, applies pressure to the top of the crystal. It is going to be apply some, let it be, this is the this is the transducer, and this is the like that. This is the pressure port. Upon this one, some pressure is applied, and some force and some force is going to be exerted upon this force summing member, and variations is takes place upon this crystal, and it is going to give some output voltage. Variations will take place, and it is going to give some output voltage like this. This is a small diagram. We will see the actual diagram. Hmm. Here pressure to the top of the crystal, this produces the EMF here. This produces the EMF across the crystal proportional to the magnitude of the applied pressure. Whatever the pressure I am applying here, that is proportionately EMF is going to be acquired here. That much amount of EMF I am going to be acquired here. The basic expression for the output voltage is given by E is equal to Q by Cp, where Q is the charge, Cp is the shunt capacitance here, where Q is generated charge and the Cp is shunt capacitance. This is about basic theory for this piezoelectric transducer. It, its material is quartz, Rochelle salt, barium titanate. It is going to produce some EMF whenever some stress is applied to that material. This property is known as piezoelectric property, and these transducers are known as piezoelectric transducers. Okay, here some external applied force is applied through the pressure port. That pressure is going to be applied on the top of the crystal. This produces the EMF across the crystal proportional to the magnitude of the applied pressure. The basic expression for this output voltage is given by capital E is equal to Q by Cp, where Q is the charge and Cp is the shunt capacitance. This is the diagram. This is the actual diagram. Here, this is the shunt capacitance, and this is the force summing member, and this is the piezoelectric material. Piezoelectric material, this is the, I am going to consider this as crystal. This is made up of barium titanate Rochelle salt quartz crystal. uh, Salt Rochelle salt quartz crystal. Here this is the base. Actually it should be like this. This is the base. This is the base for this material. This is the base. Okay, from this, from these two terminals I am going to acquire the output voltage here. Output voltage here, and some pressure, some pressure part, some pressure part here, it is going to be maintained like this. Some pressure part is going to be maintained like this. Upon this pressure part, some pressure is applied, then it is transmitted to, in terms of some force, it is transmitted to the force summing member. This force summing member will make this will make this membrane move towards downwards, and this is applied to this quartz crystal. Some deformation will take place inside this quartz crystal. The alignment of the charged particles is going to be varied, or a deviation in the charge particle alignment will take place, and I am going to acquire some output voltage here. That output voltage, that potential E, that potential E is going to be out, is going to be acquired. That is given by E is equal to, that E is equal to, anyone, that E is given by, that E is given by, anyone please respond. That E is given by Q by Cp. Q by Cp. This is the output voltage in terms of that the charge and shunt capacitance. This is the shunt capacitance. Okay, this is the, this is the diagram for piezoelectric transducer, and this is the equivalent circuit diagram for the quartz crystal. This is the quartz crystal. This is the equivalent circuit diagram. Here in this AC excitation signal is given, RLC components are maintained, and one shunt capacitance. This is Cp. This is the shunt capacitance. Here, the variation in this quartz crystal, all these are in series. R1, C1, R1, L1 are in series, and one shunt capacitance is maintained. This is the equivalent circuit diagram for quartz crystal. This is very important. You need to draw this one as well as this one. Here, this is the, this is some block diagram, just like a block diagram. This is the piezoelectric transducer I am maintaining here. This is, let it be, this is the piezoelectric crystal. Actually entire setup is known as transducer. This is the actually this is the piezoelectric crystal is maintained. Let it be this is one electrode and this is another electrode. The this is the thickness width, all these components is given here. Some force is given upon this piezoelectric crystal. Then I am going to acquire the output voltage here. Okay, this is the simple diagram. From this diagram, I'm from this diagram I can acquire the voltage. I can place some voltmeter here and acquire the voltage like this. Okay, here this is the practical piezoelectric transducer. This is a piezoelectric transducer. This is the practical one. We can use this in our in projects also. Okay, this is about piezoelectric transducer. It consists of this is the four summing member, shunt capacitance, base in between piezoelectric crystal, and some pressure port. Pressure port is also going to be given like this. This is the pressure port. Okay, by this pressure port, that force is exerted upon this piezoelectric material, and from this piezoelectric material I can acquire change in I can acquire the deformation will take place in the piezoelectric material, and after that I can acquire the change in the output voltage. Okay, you are supposed to draw this these two diagrams. These two diagrams are very important. This is for knowledge sake. These two diagrams are for knowledge sake. Okay, shall we move on? Hmm. Piezoelectric transducer. For a piezoelectric element under the pressure, the part of the energy is converted to an electric potential that appears on the opposite faces of the element. Analogous to a charge on the plates of a capacitor, it appears to be just like a capacitor. This is one plate. This is one plate. This acts as dielectric material. It is just like a capacitor. It is just analogous to the charge on the plates of a capacitor. The rest of applied energy is converted to mechanical energy and analogous to the compressed spring. It acts as this is just like a compressed spring. Okay, four summing member. It is acts as a compressed spring. Here, when the pressure is removed, it returns to its original shape and loses its electric charge. ప్రెషర్ని మనం తీసేసాం అనుకున్నాం, మనం అప్లై చేసిన ప్రెషర్ని తీసేస్తే ఇట్ రిటర్న్స్ దట్ పీజో ఎలక్ట్రిక్ క్రిస్టల్ ఈస్ గోయింగ్ టు రిటర్న్ టు ఇట్స్ ఒరిజినల్ షేప్ అండ్ లాసెస్ ఇట్స్ ఎలక్ట్రిక్ చార్జ్. దట్ ఈస్ గోయింగ్ టు బి లాసెస్ ఇట్స్ ఎలక్ట్రిక్ చార్జ్ లైక్ that. Yeah, the advantages of this piezoelectric transducer is the device need no external power source. It is not going to have any external power source, and therefore self-generating type. Piezoelectric transducer is a self-generating type. Disadvantage of this one is the output voltage is affected by temperature variations. ఏదైనా temperature variations ఉంటే దానివల్ల output is going to be affected. Applications. It is used in it is used in high frequency accelerometers. It is going to be used in high frequency accelerometers where the output voltage is of the order of 1 to 30 millivolts per gram of per gram of acceleration like that. Okay, it is going to be used in high frequency accelerometer, single point. Okay, this is about piezoelectric transducer. This is a simple concept and a very useful concept also. Okay. Hmm. Next, resistance thermometer. Resistance thermometer, we can simply call it as RTD also, resistance thermometer detector, temperature detector, resistance temperature detector also, RTD. ఆర్టీడీ అని చెప్పి కూడా ఉంటుందమ్మా. అది ఇది ఆర్టీడీ లానే వర్క్ చేస్తుంది అనమాట, ఇది ఆల్మోస్ట్ ఆర్టీడీ. ఓకే, PT100, the example for this one is PT100. This PT means platinum 100. The resistance of a conductor changes when its temperature changes. The basic principle is the change in the resistance will give the change in the temperature. This property is utilized for measuring of temperature. The resistance thermometer is an instrument used to measure electrical resistance in terms of temperature. We are going to measure electrical resistance in terms of temperature. Okay. The main part of a resistance thermometer is its sensing element. The main part is sensing element. The sensing element are desirable characteristics of the sensing element are first one is the sensing element may be any material that exhibits a the sensing element may be any material that exhibits a relative large resistance change with change in temperature. This it is going to sense a uh, small resistance change or large resistance change will give the variation in the temperature. That resistance change will give the variation in temperature. The material used should be stable in its characteristics. Whatever the manufacturing material is used, that should be stable here. That is, neither its resistance nor its temperature coefficient should undergo permanent change with permanent change should undergo a permanent change with use or age. It should not possess any sort of aging effect also. Okay. The relationship between the resistance and temperature should be linear. It should have the linear relationship between the resistance and temperature. The speed with which a resistive element responds to change in temperature is important. ఎంత స్పీడ్గా ఆ రెసిస్టివ్ ఎలిమెంట్కి టెంపరేచర్ అనేది రెస్పాండ్ అవుతుందో అది ఎట్లా అవుతుంది అనేది అంత స్పీడ్గా ఉండాలన్నమాట. వే ఆఫ్ రెస్పాన్స్ అంటే సెన్సిటివిటీ ఎక్కువగా ఉండాలన్నమాట ఇన్స్ట్రుమెంట్కి. The speed with which a resistive element responds to change in temperature is important when the measured temperature is subjected to a rapid variations. The size of the sensing element the size of the sensing element should be small. The size of the sensing element should be small such that less heat is required to raise its temperature and the faster is its response. సెన్సింగ్ ఎలిమెంట్ ఎంత స్మాల్గా ఉంటే అంటే మనం తీసుకునే ఈ పర్టికులర్ ఇన్స్ట్రుమెంట్ రెసిస్టెన్స్ థర్మామీటర్ అనేది ఎంత స్మాల్గా ఉంటే అంత ఫాస్ట్గా సెన్స్ చేయగలదు అనమాట. అంత ర్యాపిడ్గా వేరియేషన్ని అది అక్వైర్ చేసుకోగలదు అనమాట. అది the size of the sensing element should be small such that less heat is required to raise its temperature and fast is its response. Here, the material used for this manufacturing of this transducer is platinum, nickel, and copper are the materials most commonly used to measure temperature. The resistivity of platinum tends to increase less rapidly. The resistivity of the platinum tends to increase less rapidly. ఆ రెసిస్టెన్స్ అనేది కొంచెం తక్కువ ర్యాపిడ్గా ఇంక్రీజ్ అవుతుంది అనమాట at temperatures at higher temperatures for other materials. Hence it is a commonly used material for resistance thermometer. The temperature range over which platinum has stable, that is the range of that temperature for platinum is given by minus 260 to 1100 degrees centigrade, 260 degrees centigrade to minus 260 degrees centigrade to 1100 degrees centigrade. Here, this is the figure. This is the resistive thermometer. This is the sensing element, lead support, sheet, mounting thread, and a connecting two wires, connecting two leads. Here, this is the industrial platinum resistance thermometer, and it is going to be placed in this Wheatstone bridge. In that Wheatstone bridge I am going to have these resistances R1, R2, R3, R4, R5, and RS, and between this R3 and R4 I am going to place this sensing element here. I am going to place these two terminals here. This is one terminal and this is another terminal. These two leads I am going to place here. This is the sensing element. From this bridge circuit I can acquire the what is the change in resistance like that. Okay. shows that figure shows the industrial platinum resistance thermometer. The change in the resistance is caused by change in temperature are detected by the Wheatstone bridge. Okay, hence Hence, the temperature sensing element, which may be nickel, copper, or platinum, contained in a bulb or well. It is contained in a nickel, copper, or bulb is contained in a bulb or well, along with the balancing bridge, forms the essential components of a temperature measuring system based upon the basic principle. The sensing element RS is made up of a material. The sensing element RS here, this is the sensing element RS is made up of a material. It is going to be made up of a material. RS is made up of a material having a high temperature quotient. It should have high temperature quotient, and the resistances R1, R2, and RS are made up of resistance R5 maybe. Actually, resistances R1, R2, R3, R4, and R5 are made up of resistances that are practically constant under normal temperature changes. When no current flow through the galvanometer, the normal principle of Wheatstone bridge states that ratio of resistance is given by this is the practical RTD or PT100. PT100 ఇది ప్రాక్టికల్గా ఇండస్ట్రీస్లో యూస్ చేసే రెసిస్టెన్స్ థర్మామీటర్ ఇదనమాట. ఈ టిప్ ఈ టిప్ నుంచి ఇది సెన్సింగ్ ఎలిమెంట్. ఈ సెన్సింగ్ ఎలిమెంట్ ఇక్కడ టూ లీడ్స్ ఉంటాయి. ఆ టూ కనెక్టింగ్ హెడ్ ఉంటుంది అనమాట. ఈ కనెక్టింగ్ హెడ్ దగ్గర ఇక్కడ ఈ క్యాప్ ఓపెన్ చేస్తే ఆ కనెక్టింగ్ లీడ్స్ కనెక్ట్ చేసుకుంటాం అనమాట. ఇది ఫిట్టింగ్, దిస్ ఈస్ ప్రొటెక్టింగ్ ట్యూబ్, అండ్ ఇన్సైడ్ దిస్ వన్ విల్ బి ఏ సెన్సింగ్ ఎలిమెంట్. దీని లోపల ఇది ఉన్నట్టు అనమాట, ఈ సెన్సింగ్ ఎలిమెంట్. ఓకే, దిస్ ఇస్ ద ప్రాక్టికల్ వన్. For knowledge sake, I have given this diagram. Okay, actually you need to draw these two diagrams in your exam. Okay, ఈ diagram and this Wheatstone bridge diagram, two diagrams you are supposed to learn as well as prepare for your exam. Here the relationship is given by when no current flows through the galvanometer, the normal principle of the Wheatstone bridge states that the ratio of resistances is given by R1 by R2 is equal to RS by R5. R1 by, this is the balancing of the bridge, R1 by R2 is equal to RS by R5. RS by R5 మనకు మామూలుగా ఏంటి, R1 by R2 is equal to R3 by R4 అనేస్తాం కదమ్మా. అట్లాగా మనం ఇప్పుడు R1 by R2 is equal to RS by R5. R1 by R2 is equal to RS by R5. In normal practice, the sensing element is away from the indicator, and its leads have a resistance, say R3 and R4 is also given here. Therefore, I will take those resistances are in series with the sensing element. Therefore, that relationship can be given by R1 by R2 is equal to R3 plus RS plus R4 by R5. Now its resistance RS changes here. Hence, a big balance cannot be maintained, and the galvanometer shows a deflections here, which can be calibrated to give a suitable temperature scale. వచ్చిన రెసిస్టెన్సెస్ తోటి మనం క్యాలిబ్రేట్ చేస్తాం ఆ రెసిస్టెన్స్, పర్టికులర్ రెసిస్టెన్స్ వాల్యూకి. ఫర్ ఎగ్జాంపుల్, ఐ హ్యావ్ ఎక్వైర్డ్ ది రెసిస్టెన్స్ వాల్యూ 100 ohms like that. For that resistance, I can give the temperature of 110 degrees centigrade like that. For 110 ohms like that, and I can give the temperature 120 degrees centigrade like that. That scaling factor, that I can give some scaling factor for this resistance as well as that temperature like that. That scaling factor is going to be given in terms of resistance as well as temperature. That is a point given here. Okay, in this way, this is the basic relationship, first balancing of the bridge, and this is the final equation. The resistance RS is going to be changed. That balance of the bridge is that balancing of the bridge is, it can be maintained by maintaining some pot also. By placing some pot, we can make the balance of the bridge also is possible. Okay, this is about resistance thermometer, and we will see what is its advantages. Advantage: The measurement is very accurate. This measurement is very accurate. It has a lot of flexibility with regard to choice of measuring equipment. Lot of flexibility is there for taking the choice of measuring equipment. It can be used, it acts as an indicator, recorder, or controller, and can also be operated like this. We can use this equipment like indicator, recorder, or controller. More than one resistance element can be clubbed to the same indicating or recording instrument. ఒక రెసిస్టెన్స్ ఎలిమెంట్ కంటే కూడా మోర్ దాన్ వన్ రెసిస్టెన్స్ ఎలిమెంట్ ఐ కెన్ యూస్ హియర్. More than one resistance element can be clubbed to the same indicating or recording instrument. The temperature sensing resistance element can be easily installed. We can easily install and replaced. The resistance thermometer. Here, the resistance thermometer can be used for wide temperature ranges from 200 degrees centigrade to 650 degree centigrade. 200 degree centigrade నుంచి 650 degree centigrade వరకు we can use this resistance thermometer range. ఇవి మీరు ఏమన్నా మన కోర్ ఇండస్ట్రీస్కి ఏదైనా మ్యానుఫ్యాక్చరింగ్ ఇండస్ట్రీస్కి వెళ్ళినప్పుడు ఇట్లా ఈ రేంజెస్ అడుగుతారమ్మా. వాట్ ఈస్ ది రేంజ్ ఆఫ్ రెసిస్టెన్స్ థర్మోమీటర్ అంటే ఇప్పుడు యూ ఆర్ సపోజ్ టు టెల్ దిస్ రేంజ్ 200 to 650 degree centigrade. అట్లానే నెక్స్ట్ వచ్చే అప్కమింగ్ టెంపరేచర్ ట్రాన్స్డ్యూసర్స్ ఉంటాయి. ఆ టెంపరేచర్ ట్రాన్స్డ్యూసర్స్ ఏంటి, థర్మిస్టర్ అని చెప్పి ఉంటుంది, థర్మోకపుల్స్ అని ఉంటాయి, అండ్ డిఫరెంట్ టైప్స్ ఆఫ్ దిస్ ఆర్టీడీ ఈజ్ ఆల్సో కమ్స్ అండర్ టెంపరేచర్ సెన్సింగ్ ఓన్లీ. These are the best suited for remote indication. It is going to be used in autonomous industries, and it can be we can acquire the temperature from remote location also. ఇది మనం అక్కడ ప్లేస్ చేసాం అనుకున్నాము, ఒక పర్టికులర్ ఇండస్ట్రీలో బాయిలర్ దగ్గర ఈ ఆర్టీడీని ప్లేస్ చేసి వీ కెన్ అక్వైర్ ది టెంపరేచర్ ఆల్సో. అట్లా కూడా చేయొచ్చు అనమాట. ఇట్ ఈస్ బెస్ట్ సూటబుల్ ఫర్ రిమోట్ ఇండికేషన్ ఆల్సో. The resistive element response time is of the order of 2 to 10 seconds. It is going to give some output within 10 seconds. The limit of error of a resistive element is plus or minus 0.25 percentage. Plus or minus 0.25 percentage of the scale reading. The size of the resistive element may be of about 2 to The size of the resistive element may be of about 6 to 12 mm in diameter and 12 to 75 mm in length. The diameter is 6 to 12 mm and the length is 12 to 75 mm. No necessity of temperature compensation. Temperature compensation ki ఎటువంటి టెంపరేచర్ కాంపెన్సేషన్ చేయాల్సిన పని ఏమీ లేదమ్మా మనకి ఈ ఎక్విప్మెంట్ యూస్ చేసేటప్పుడు. అదే వేరే డివైజెస్కి అయితే టెంపరేచర్ కాంపెన్సేషన్కి వేరే ఒక అదర్ సర్క్యూట్స్ వీ నీడ్ టు ప్లేస్ అండ్ వీ నీడ్ టు కాంపెన్సేట్ దిస్ టెంపరేచర్ లైక్ దట్. Stability of performance over long period of time is also very good for this resistance thermometer. Stability of performance is very high. Disadvantages of this resistance thermometer: its cost is high, need for bridge circuits and power sources. We need to have the bridge circuit as well as power source. External power source is also required. Possibility of self heating is also there. Possibility of having the self heating effect అవటానికి ఛాన్సెస్ కూడా ఉన్నాయన్నమాట. ఆ సెల్ఫ్ హీటింగ్ ఎఫెక్ట్ అయితే ఎంటైర్ డివైస్ ఈజ్ గోయింగ్ టు బి in the corrupted state or in the destruction position. ఆ సెల్ఫ్ హీట్ ఎక్కువగా జరగకుండా చూసుకోవాలన్నమాట. హీటింగ్
వాయిస్ లాగ్ వస్తుంది సార్.
వాయిస్ ఏంటమ్మా స్లోగా వస్తుందా వంశీ? ఇప్పుడేనా? ఇందాక నుంచి అట్లానే ఉంది.
మధ్యలో జస్ట్ ఇప్పుడే సార్ వాయిస్ లాగ్ వస్తుంది.
ఇంటర్నెట్ డౌన్ అయింది. అప్పుడు కొంచెంసేపు ఆపానులే నేను. ఇప్పుడు ఎట్లా ఉంది? ఇప్పుడు ఓకేనా?
ఓకే సార్, ఇప్పుడు బాగానే ఉంది సార్, నార్మల్ గానే.
ఓకే అమ్మా, ఓకే, థ్యాంక్ యూ. Disadvantage is high cost, need for bridge circuit, and we need to have some bridge circuit as well as external power sources is also required. Possibility of self-heating. Self-heating is also a possibility of self-heating. This is a major disadvantage. Why? Because ఈ హీటింగ్ ఎఫెక్ట్ వల్ల ఏంటంటే డిస్ట్రక్షన్ ఆఫ్ ది ఇన్స్ట్రుమెంట్ మే టేక్స్ ప్లేస్ హియర్. ఓకే, మనకి థర్మల్ రన్ అవే కాన్సెప్ట్ తెలుసు కదా. ఆ థర్మల్ రన్ అవే కాన్సెప్ట్లానే ఇక్కడ సెల్ఫ్ హీటింగ్ అనేది ఎక్కడ మనకి జరగకూడదు అనమాట. అది అలాగ. Here, large bulb size compared to the thermocouple. Here, the bulb size of this material is very large. Thermocouple size is very small when compared to this resistance thermometer. Okay, this is about resistance thermometer RTD. That is RTD, or we can call this as PT100. Simply, this is the diagram. This is the diagram for PT100. Okay. First, anyone? Let me. Sai Krishna, B8 Sai Krishna, B8 Sai Krishna, B8 Sai Krishna. F6 Lokesh, F6 Lokesh, F6 Lokesh, Pavan G0 Pavan.
Sir.
పవన్ ఇది ఒక్కసారి పీజో ఎలక్ట్రిక్ ట్రాన్స్డ్యూసర్ బేసిక్ ప్రిన్సిపల్ చెప్తావా? మనం ఇప్పుడు డిస్కస్ చేసుకున్నది. సింపుల్గా చెప్పి, సింపుల్గా ఈ డయాగ్రామ్ చూడు, ఈ డయాగ్రామ్ చూసి చెప్పు. ఈ డయాగ్రామ్ చెప్పవని పర్లేదు, నేనేమన్నా హెల్ప్ చేయనా? ఇక్కడ ప్రెషర్ పోర్ట్ ఉంటుంది, ప్రెషర్ పోర్ట్ ఉంటుంది. అపాన్ దిస్ ప్రెషర్ పోర్ట్, upon this pressure port I am going to apply some pressure, and it is transmitted to the force summing membrane. Thereafter, the movement in this force summing membrane, just like it acts as a spring, and that force is exerted upon this piezoelectric crystal. Deformation inside this piezoelectric crystal will take place, and the output voltage I am going to equate. That output voltage is in terms of some charge as well as shunt capacitance. Charge as well as shunt capacitance. This is the basic principle of piezoelectric transducer. అంతే కదా? ఓకే ఓకే, థ్యాంక్ యూ ఫర్ యువర్ రెస్పాన్స్. అసలు రెస్పాండ్ అవ్వండిరా బాబు, మీరు చెప్పినా చెప్పైనా రెస్పాండ్ అవ్వట్లేదు, అదే వచ్చింది నాకు తంట. ఎల్ఈ పవన్ 8, రోల్ నెంబర్ 8 పవన్, ఎల్ఈ పవన్. ఎల్ఈ పవన్. శ్రీనివాస్ 19 శ్రీనివాస్. చైతన్య 26 చైతన్య. మిమ్మల్ని అందరినీ పిలిచి టైం వేస్ట్ ఎందుకు కానీ నెక్స్ట్ one is resistance thermometer. The basic principle for this one is change in the resistance will take place with respect to the change in temperature. Okay, here we are going to use the material is platinum. Material is the maximum range for this platinum is minus 260 degrees centigrade to 1100 degrees centigrade. For this RTD is the maximum temperature range, the change in resistance, the basic principle is the basic equation is R1 by R2 is equal to balancing equation is R1 by R2 is equal to RS by R5, whereas here that equation is going to be converted into R1 by R2 is equal to R3 plus RS plus R4 by R5. The deflection will take place upon the galvanometer here. Okay, the maximum temperature operating temperature range is 200 degrees centigrade to 650 degree centigrade. It can be used as this RTD can be used as indicator, recorder or controller here. We can use this instrument in remote locations also. No need of temperature compensation. Stable performance will be acquired by this instrument. Disadvantages is costly. We need to use bridge circuit, external power source, self-heating effect may take place. Here bulb size is very heavy compared to thermocouple. This is about resistance thermometer. Please go through once again. I will post this PPT in your group. Okay.